Good morning, students. Today I'm going to discuss about molecular orbital theory. So in this, you can learn shortcut method for calculating that molecule is a paramagnetic or diamagnetic, or the molecule is existed or not. We can calculate by this shortcut method, and bond order, how to calculate the bond order, and how many bonding electrons are there and how many anti-bonding electrons are there. That one also we can calculate based on this shortcut method. So now come to the shortcut method. Here, first of all, here number of electrons. After that, anti-bonding electrons or bonding electrons. This is the bonding electrons. This is we are represented by Nb. Next, anti-bonding electrons. That is we are represented by Na, anti-bonding electrons. And after that, bond order. And after that, it is a paramagnetic or diamagnetic. We can calculate diamagnetic. And this molecule is existed or not. Existed or not. So by this shortcut method, any molecule or any ionic spaces they given. So that ionic spaces or molecule, how many that having how many electrons totally, and in this how many bonding electrons are there and how many anti-bonding electrons are there, and what is the bond order of that molecule, and that molecule is a para or diamagnetic, and that molecule is existed or not, we can calculate. So now first of all, number of electrons are 14. Number of electrons are 14. This one you have to remember. So number of electrons are 14. Then bonding electrons are 10. Anti-bonding electrons are 4. Anti-bonding electrons are 4. Next, bond order is the 3. Bond order is the 3. Why? Because bond order, what is the formula? That is the bonding electrons minus anti-bonding electrons by 2. So 10 minus 4 by 2, that is the 3 value. So these values you have to remember. Totally 14 electrons. If that molecule or ion having 14 molecules, then bonding electrons are 10 and anti-bonding electrons are 4 and bond order is 3. So now coming to 15 electrons, means that molecule or ion having 15 electrons. Write down here 14, 15, 16, 17, 18, 19, 20. So these many electrons, for example, Ne2 molecule, that is the totally neon having 10 electrons, 2 neons having 20 electrons, like that. Any molecule or ion species having like these electrons, then you have to fix number of bonding electrons 10 only here. So 10, for 16 also 10 bonding electrons, for 17 also 10, 18 also 10, and 19 also 10, and this is also 10. Now anti-bonding electrons you have to increase by 1. Then anti-bonding electrons 5. Then total electrons are 15, bonding electrons are 10, and anti-bonding electrons are 5. And after that, this is the 6, 7, 8, 9, 10. So these are the anti-bonding electrons. So in this, which one is fixed? Bonding electrons are fixed. From 14 to 20, bonding electrons are 10 and anti-bonding electrons will be changed. After that, bond order. 14, for 14 electrons, bond order is 3. Then 15 electrons, you have to decrease 0.5 value, we have to decrease. Then this is the 3, then this is the 2.5, this is the 2, 0.5 we have to decrease. Then this is the 1.5, this is 1, this is the 0.5, and this is the 0. So this is the bond order. Like this we can calculate 3, 2.5, 2, 1.5, 1, 0.5, 0. If electrons are increased, bond order from 14 onwards, we have to decrease 0.5. Then for example, 16 electrons it having, then 16 electrons, what is the bond order? That is the 2. Directly we can write. And 18 electrons is there, means that bond order is 1. So this is the shortcut method. And above also same like that. Here 13, 12, 11, 10, 9, 8 electrons. Up to 8 electrons we can collect. Now from 14 to 20, bonding electrons are fixed. Bonding electrons are fixed. Now from 14 to 8 antibonding electrons are fixed. Then here for 8 antibonding electrons are 4, 9 also 4, 10 also 4, 11 4 antibonding electrons, 12 and 13 also 4 antibonding electrons. So from 14 to above antibonding electrons are fixed. From 14 to below means up to 20 electrons, bonding electrons are fixed. Now here bonding electrons, here antibonding electrons are 4, then these are the 4 only. Why? Because 8 electrons here, 9 total 9 electrons, on that antibonding electrons are 4, then this is the 5, after that 6, 7, 8, 9. So these are the bonding electrons and the antibonding electrons. From 14 to 20 bonding electrons are fixed, 10 only. From 14 to 8 antibonding electrons are fixed, then remaining you have to add like this. Now bond order, from 14 to 20 0.5 decreased, same like that from 14 to 8 also 0.5 decreased only. Then for 14 electrons bond order is 3, then 13 electrons 2.5, and 12 electrons 2, and 11 electrons 1.5, 10 electrons 1, and 9 electrons 0.5, and 8 electrons, that is the bond order is 0. So like that bond order directly we can write. Now in this which is a paramagnetic and diamagnetic, all odd number of electrons totally paramagnetic. Here odd number of electrons 9, so 9 is a para. Next 11 is a para. Next 13 is a para. Next 15 also para. Next 17 also para. Next 19 also para. So all paramagnetic, all odd number of electrons having which nature, that is the paramagnetic nature, and even number of electrons, that is diamagnetic, but except 10 comma 16, except 10 comma 16, those are the, actually these are the even numbers, 10 and 16 even numbers. So we think about like diamagnetic, but 10 and 16 except 10 comma 16 remaining even numbers, even number of electrons are dia. So 8 dia, next 12 dia, next 14 also dia, and after that 18 dia, next 20 is also dia. So like this we can calculate. Now 10 and 16 are the even numbers, but these are the paramagnetic nature. So these are the paramagnetic nature. So in this, how to calculate the para and dia means all odd number of electrons from 8 to 20 electrons, odd number of electrons. Now how to calculate that molecule is a paramagnetic or diamagnetic, we have to calculate. So in this 8 to 20 electrons, all odd number of electrons are para. So that's why 9 means para, and after that 11 para, next 13 also para, next 15 also para, next 17 para, and 19 also paramagnetic nature. So all odd number of electrons give the paramagnetic nature, and even number of electrons, so even number of electrons dia only, but except 10 comma 16, actually 10 comma 16 are the diamagnetic even numbers, but these are the paramagnetic nature. All even number of electrons are diamagnetic except 10 comma 16. So 10 comma 16 are the paramagnetic nature, 10 comma 16 are the paramagnetic, remaining even numbers diamagnetic. So 8 is a diamagnetic, next 12 is a diamagnetic, 14 also diamagnetic, and after that 18 also diamagnetic, and 20 is also diamagnetic. So this is like that we can calculate that molecule or ion is a paramagnetic or diamagnetic, we can calculate. Next, that molecule is existed or not. Existed or not, how to calculate means, if bond order is 0, then that molecule is not existed. So for 8 electrons bond order is 0, and 20 electrons also bond order is 0. For example, Ne2 molecule, this is the neon. Neon is a noble gas element. Noble gas element is a monoatomic gas, but here Ne2 means it is a diatomic. So Ne2 is not existed. Based on this we can say bond order is 0, so Ne2 molecule is not existed. Noble gases are existed as a monoatomic gases like neon, like this only it can existed due to bond order is 0. So this one, which molecule or ion having bond order is 0, that molecule is not existed. For example, helium 2 molecule the given, or helium 2 molecule the given. Helium 2 molecule, helium having how many electrons? 2 electrons. Why? Because its atomic number is 2. So helium contain 2 electrons, but here helium 2. So totally 4 electrons. So 4 electrons. So actually here 8 to 20 only I said. Below 8 electrons, how to calculate? For example, helium 2, how many electrons it having? 4 electrons. Then write down the configuration for according to molecular orbital theory, that is sigma 1s2 and sigma star 1s2. Sigma star 1s2, totally 4 electrons in this sigma 1s2 and sigma star 1s2. Sigma 1s without star, that is the bonding electrons. With star, that is the anti-bonding electrons. Now bond order equal to bonding electrons minus anti-bonding electrons by 2. So this is the formula. Directly we calculated like this. We can say directly by based on the table. Directly we can say. But bond order how to calculate means bonding electrons minus anti-bonding electrons. For example, 12 bonding electrons are 4, bonding electrons are 8, and anti-bonding electrons are 4. So 8 minus 4, 4 by 2. Then bond order will be 2 only will come. So here bonding electrons for the helium 2 molecule, bonding electrons are 2 minus anti-bonding electrons are 2 by 2. Then 2 minus 2, 0, 0 by 2, 0. So what is the bond order? Bond order is 0. So bond order 0 means this helium 2 molecule is not existed, this one. Why? Because bond order is 0 for this. So helium 2 molecule is not existed. Why? Because helium is a noble gas element. So noble gas element is not existed as a diatomic molecule. It is existed as a monoatomic gas only. So based on bond order, we can say it is not existed. Helium 2 diatomic molecule is not existed. Thank you.